This is the 150th anniversary interview with Tim Berners-Lee. Where were you born and where did you grow up?
I was born and grew up in London, England.
And I've had great fantasies about how your dinner time conversation probably went at home, but tell me a little about your parents.
Well, they met designing, working on the first computer to be commercialized in the UK, the Ferranti Mark I, which came out of Manchester University. And they're both mathematicians, so I suppose I grew up in a house where mathematics was everywhere, was celebrated, and it was found everywhere. So if you're cooking, then, or you're trying to, whatever you're trying to do, then it'll be an excuse, a reason for noticing that mathematics comes up.
Besides the influence of your parents, were there any other significant events or influences that you remember from your childhood that you think impacted your career?
Taking me towards technology and things. Well, I suppose I built stuff. The fact that my parents kept a scrap mat drawer, scrap materials drawer, so that if you wanted to make something, you could go and find out what was in it. And my mother would secretly throw things in as something like a dishwashing liquid bottle became empty. She'd put it in there, and just as a surprise, because dishwashing liquid bottles have these tops which you can use for axles, and they have bottles which you could use for funnels and things. So that, and I think that the idea of a scrap mat drawer came from a local teacher training college. We had students staying in the house. Then after that, I suppose in high school, my math and chemistry teachers were both very enthusiastic and encouraging.
What was it about, what drew you to Queen's College?
Complete random chance. Given the list, I was entering on math. And when you do enter Oxford Math, in those days anyway, you had a choice of all the colleges. You weren't restricted to a particular group. So I had really no idea. It looked like it was a medium-sized college near the middle. So I had a great time there, but I had no idea how to pick them.
Yeah, sounds how 18-year-olds make decisions.
It still seems to be.
Yes. How did you transition, or how did you decide to make the transition from math to physics?
Well, I was good at math and had enjoyed math, but on the other hand, what I did at home was build stuff out of electronics. So that was sort of electronic engineering, and I was torn those two ways. So I thought that physics would be in between. Math on one side being more theoretical and engineering being more practical on the other side. That was, I think, the logic that took me to apply to do physics at Oxford. And I found out it was something completely different. I don't know that physics really is a totally separate subject in its own right, and related to both, but I enjoyed physics a whole lot too. And when, in some ways, maybe it ended up being a really good choice.
And wasn't it there where you built your first computer?
I did. I started off building a display unit. So in those days, the display unit and the computer were separate, and there was a serial cable connecting the two. So the first thing I started was with an old television, building turning it into a character-based display, and then building a keyboard, a QWERTY keyboard, by putting together banks of switches that I'd found discarded, and rubbing letters onto them and painting them and varnishing them and so on. So painstakingly built the display unit, and then just about at the end of my time at Oxford, I got a microprocessor chip and had a big rack-mounted computer system.
Were there particular mentors or professors at Cambridge who were influential?
Very few. I went to Oxford.
Oxford, sorry.
A lot of people, when they go to Oxford, they have a tutor. They have different tutors for different parts of the subject. But John Moffat was my physics tutor, and he taught me for all 3 years basically everything. So which was for me, which was great. He was enthusiastic, quiet, in a quiet sort of way. He'd very quietly allow you to bring your work in, and he'd go through it and explain where it could have been better, and then explain where what you should think of what you should do next. But he'd do it very much in your own pace, rather than he'd never stuck with the pace of the lectures. In fact, he was often teaching a different subject to the ones which were being lectured on by the university at the time. We found out that different students were doing completely different things, but he just arranged it for each student as he thought fit for them. He had a great knack of being able to seeing it from your point of view. If you bring him something worked out, I'd sort of find my own way of figuring out some quantum mechanical thing, and he would come, and I'd use totally different symbols to the way one normally would. I'd come to it a completely different way, and he would look at it from my point of view, take all that on, and then show me where I'd gone wrong in my terms, and then which was a great ability not many people have.
Now, when you graduated, you chose not to go on immediately for an additional degree. You decided to work at CERN, I think?
No, when I graduated, well, I didn't really have any role models for people doing a next step in physics, and I didn't really want to go into a particular narrow branch of physics. I think maybe if I'd have known more about the world, what I probably would have advised myself would have been to go to the States, do a master's and then a PhD in computer science. But Oxford didn't have computer science at that stage, and I didn't really have any role models who were enjoying doing a PhD. But the microprocessor revolution was happening. You could suddenly buy a computer this big, and the telecommunications companies needed people who understood how to take a big rack full of electronics and replace it by programming a chip. And so that world was beckoning.
So why don't you walk me through some of that early work? Like, I know you were at Plessey Telecommunications, you were at CERN and DG Nash. Tell me a little bit about, what you were doing at each place.
Well, Plessey Telecom was a big telco. So they made telephone exchanges, but I worked in a little area which was doing things with microprocessors. At the time when I arrived, they had a groundbreaking device, a barcode reader, which you wheel around a supermarket. This barcode reader is I think it had a car battery in the bottom, and then it had a rack full of 7-inch cards. It was all designed in the hardware, and it had a wand on it. And Sainsbury's, the supermarket, were breaking new ground by tracking the stock they had on the shelves and sending to the store exactly what was needed. So they saved having to have a storeroom above the shop. So this was a revolution in how to run a supermarket, and it was being made by this trolley that you'd run with a car battery in the bottom. When I arrived, the group at Plessey were replacing that with something the size of a sort of large transistor radio, which it had a tape on which it recorded the barcodes read, and they had a microprocessor inside it. So that's sort of the change that was happening. The bits I worked on were barcode readers for library systems. So when you brought back a book, somebody could scan it to find out whether somebody else had reserved it. Very simple system to save people a lot of time, and we used these microprocessors to do that.
Okay.
So I design, where there had been a board full of electronics, I designed some electronics to interface to the microprocessor, so that the microprocessor could emulate the electronics that had been there before, and then program the microprocessor. And
then what'd you move on to?
Well, I was at Plessey for 2 years, and then a very good buddy of mine, Kevin, had left to join a startup And he called me and said that they need 2 programmers, not 1. So that made a total of 4, the 2 hardware engineers, John Poole and Dennis Nash. And Kevin Rogers and I went joined them as programmers because they were doing the same thing. They'd made smart printers, and these printers, dot needle printers, which had a head which moved backwards and forwards, which were driven completely by electronics. And they were doing the same thing. They put a microprocessor in, realized they could do a whole lot of interesting things, but needed people who knew how to program it.
So you are definitely building toward computer science.
Well, programming computers, I had this computer which I had at home, and so that was progressing as well at the same time. That was a 6800. Nobody I worked for used a 6800, but I slowly the price of memory was coming down, so you could get more and more memory, so I could write an interpreted language, which would mean I could program it more effectively, and so on. So there was so that was all. It was a very exciting time, really, both at work and at home, thinking of all the things you could do.
So how did you wind up working at CERN?
CERN had a minor crisis because they were these great big accelerators that they build have big control systems as well, and there was a set of control systems for the proton synchrotron and the systems around it, which had to be ready at a certain date. Their new control systems were all based on mini computers, so it was a software issue, and they went out looking for people. They went to contractors looking for to bring in people like hiring a bunch of cowboys, to basically to round up the herd. They needed people to fix this, and so they a whole bunch of contract programmers arrived, and Kevin and I were 2 of them.
You wound up leaving CERN and then you went back there. Is that correct?
The first 6 months, it seemed like a year at the time. It seemed that we'd done everything. We learned to ski, even though we must have been there for only a few weeks of snow. So yeah, that was just for 6 months, from June to December.
Mm-hmm. And then where did you leave there to go?
Then John Poole and Dennis Nash had split up. John Poole was starting a new company, Image Computer Systems, and Kevin and I went back to help him.
And then tell me about going back to CERN. That was a fellowship, I believe.
That was in 1984. Then I left the UK to go back for what was supposed to be 2 years as a fellow. I knew CERN, and it was a fun place to be. They had these fellowships in which you would come along, and I think we're supposed to do things which were useful to your own education, as well as helping get CERN working. But mostly people ended up just putting their sort of shoulders to the wheel, getting all the software written.
Can you walk us through the story of the origins of the World Wide Web and HTML, and how that thought process developed?
Well, so I ended up. I went for 2 years. I ended up there for 10 years. And during that time, I had a number of projects in which I had an idea about how things could work. I put it out there, and I needed volunteers from other groups to work on it. CERN didn't have a very centralized pyramidal hierarchical management structure, because people came from different universities. Physicists came having designed pieces of equipment, and of course they had to collaborate very well, because each piece of equipment had to fit together, eventually be lowered down a few hundred meters below the surface, and then work under rather extreme conditions. So, but all the same, it was not a military-like place. So people arrived with different computers. They arrived with different documentation systems. So when you wanted to know what was going on, you'd have to find, you typically have to be introduced to the person. So the coffee areas were really important. They still are, and of course. The coffee areas still are important, but at that time they were crucial because talking about things, you'd get introduced to the people who'd written other pieces of the system or designed different pieces of the hardware, and then when you'd nailed them, you'd try to remember their face and trying to get a clue as to where they might have buried the documentation, what system it would be on. So back then, this is 1989 was when I proposed the web, but I thought about it for years beforehand. We'd got to the stage where computers were running different operating systems. There were Unix-based computers, VAX VMS-based computers, and different flavors of Unix. And no, there was a mainframe computer running its own operating system. So there were different flavors of software, different flavors of hardware. They were actually connected. And the internet was just starting to become available. So although the people didn't, in practice, transfer files very much from one computer to another, you could if you knew how. So if you knew that somebody had written the document that you wanted, and it was on another computer, and as they were both connected to some sort of network, with enough research and with installing enough bits of program, you could install things like Telnet, the remote login program on both, and you could Telnet over to another system and run some programs there which would allow you to route about for the information. Eventually, you could transfer it back to the terminal you're using. So that wasn't really a great way to get information. There was, but on the other hand, there was such a potential. There was so much information which was actually sitting there on disks, going round and round, carefully prepared by somebody, lovingly prepared, documentation of the project they'd been working on for the last 5 years, they'd lovingly written up, with references to other documents, which again we'd have to go through the same process to find. So once you had the idea that actually this could all be part of one virtual documentation system, in which you just click when you want to follow a reference, then it becomes pretty compelling. That it was difficult to explain to people because the web was a paradigm shift. It was really the idea that you could get that any document could be available in a click was just too difficult to explain. Only a few people got it, but that was enough. A few people each time somebody would talk about it, a few people in the room would get it. The others would go away shaking their heads.
So you wrote a grant, or you asked for some money to pursue this?
Not really. There was nowhere for me to do that. There was nowhere for me to ask for a grant because the CERN didn't do software development. If it had, all kinds of people physicists would have decided their word processor was not good enough, and there would goodness knows enough rewritten word processors properly. And so CERN had a very thick skin when it came to people saying, I'd like to rewrite some of the software, I'd like to write a new documentation system. People had, in fact, been asked to write new documentation systems, but they always ran on one particular machine, so that they'd be fine for people running on that machine. And also they tended to tell you how to think. They tended to insist that you put your documents in a tree or in a matrix or something, which if you're a tree person, the matrix doesn't appeal and vice versa. So the systems which people had tried out the systems which you could buy, and they tried building them, and none of those systems had worked. So really, there was somewhere where I could go if I wanted to make a new physics experiment. I could take it to committees who were set up to look at the pros and cons of different physics experiments. But for a new software project, then there was nothing set up. So I wrote a memo, distributed it in March 1989. I sent it to a few people that I knew. A year later, somebody asked me, what about the hypertext idea that you were talking about? I said, well, I wrote a memo. I think I sent it to you. And they said, oh, send it around again. So I sent it around again, labeled March 1989, comma, March 1990, just to rub it in. March 1989, comma, May 1990. And again, sort of fell on stony ground. But then my boss let me do it in my spare time the following September.
I bet he's glad that he did.
If he were alive today, I think Mike Sendall would be very bemused by the whole thing. We didn't know at the time, but when we went through his people went through his things after he died, he they found the original proposal I'd written in his handwriting in pencil vague but exciting, as the written on the top of it.
When you first started to work on this, after you finally got the okay, what would you say were the sort of 2 or 3 biggest obstacles you had to deal with? I mean, one of them may have been that people didn't quite understand where this could lead, but what would you identify as the biggest obstacles you faced?
I think the paradigm shift that I could show them a page of hypertext and click on a link. In the original browser, that would cause a new window to come up with a new document in it. And it's no good saying sort of ta-da. They'd say, yeah, we've got things like that. We've got help systems which will do that. The ta-da is now, when we followed that link, it pulled the document off the internet, and it could have got any document, potentially. So they say, well, so what documents are there? Well, I've got some documents about the World Wide Web project. So, okay, big deal. So the problem was getting the ball rolling. There was a chicken and egg thing, so where the chicken and the egg were the servers and the browsers. Until people had some servers running with some interesting information on them, nobody was going to install a browser. Until people had browsers running, who was going to put up a server? But in times like this, there are some people who do get it. So a few people I'd explain the system, and they say, wow, you mean that could have gone to something on my machine? So I could put something, what do I have to do to put something into the system? Do I have to ask you? I don't have to, I can just do it, I can just run a server? Okay. So then I get an email back from somebody saying, I'm running a server, here it is. And then I make a link to it. Kept a link of all the servers links to all the servers that people told me about early on. So those people got it. And fortunately, so those people put up a few servers. One of the ones which we very deliberately put up was a CERN phone book, because there was an outstanding need. Everybody had to log on to the mainframe because that's where the CERN phone book was. The CERN phone book was a database which has been put together by merging information from the HR database and information from the computer users database. And those two, that merge was done across a firewall, which normally there was no connection, no network connection. So somebody had to transfer some sort of physical medium in order to create that. So the social arrangement behind the CERN phone book, the online phone book, had taken a lot of energy to create. And so that was exactly the sort of situation where the web was ideal. You just had to leave that, say, don't change it. We'll run a little program which allows people to access it from outside the web. So for some people, they knew the web initially as a weird sort of phone book.
So what was your original vision for what the web would be?
Well, the web wasn't the first project I had where I had an idea, wanted other people to work on it. So the idea, the situation I was in was writing software, creating systems with the help of other people, typically people who, for one reason or another, they thought it was a good idea. They didn't necessarily have their boss's permission to work on it. But we formed these informal collaborations. And so the idea was that it should be a play space. What I was interested in wasn't just in it being something in which finished documents would go. What I was really interested in was capturing the meetings and all the things discussed in the meetings. I was really interested in capturing the process, so that I imagined, supposing a student comes for the summer, I'd like to be able to just point them at the project and say, look, this is where we are. This is what the design is. If you're interested in how we got there, here's the paper trail. You'll be able to burrow down and find why we made this decision. So you'll be able to go to look at the background documents that we had when we made those decisions and so on. So I was interested in it being an encapsulation both of the design, which was being collaboratively evolved, but also an encapsulation of all the social processes going on around it. So it really was supposed to be a play space. It was supposed to be a place where you together make a hypertext design of something, a bridge, a program, whatever it is. And because you've done it together in hypertext, then it's available for other people to get up to speed very quickly, and it becomes a resource for everybody else.
So then how did that original vision change as you worked through and developed more and more of the web?
Well, the original vision was, to a certain extent, instantiated in that first program I wrote, the first web browser editor. It wasn't just a browser, it was an editor. So while you were looking at a web page, you could correct a spelling mistake and say save, and it would save the web page back. Or if you thought, oh, that's interesting, I think that's idea is connected to this idea that I saw before. You could go to find the other idea. You could press the mark combination, highlight a phrase, press mark, go back to where you were in another window, highlight something and press the link keys, and the hypertext link would be made. So in real time, as you were thinking about the problem, you could make a hypertext link. So that and that program ran on the next machine. Now, the next machine was a wonderful machine. It was a magnesium black box that Steve Jobs put together when he sort of rebelled from Apple and put together Next. But not a lot of people had it. And in fact, at CERN, in a rather unusual attempt to rationalize, it was decreed that no one should buy them. So there was something like 12 on site. So that was really disappointing. So the web had spread to be as a collaborative medium, an editable space, among people who had the next machine. But then various other people wrote browsers. Payway made one called Viola, and that was a very interesting browser because it had scripts in it, a little bit like the dynamic sort of pages that we get today. There was Cello, there was Midas, and there was Mosaic, which Mark Andreessen put together, which was about the fourth browser, and that became very popular. But these were all just browsers. So the moment people knew the web as being something you see from a browser, suddenly it became not a completely passive medium, not as passive as television, but a whole lot more passive than the read-write web, which had been the design goal.
At the origin of this, how long did you think it would take for the concept of the web to spread? How did you sort of see it developing, and how is that different from the way it developed?
I didn't really have any plan for it spreading at a particular speed. All the time I was worried about the thing falling over, being overtaken by something else, falling foul of rumors that you'd have to pay royalties or the various different ways in which it could get tripped up, or just fizzling out. So it was going up exponentially, but a lot of things do this. And so we were always worried that it was going to do that. And so, in fact, on the logarithmics, going through the orders of magnitude factor of 10, over the first 3 years, the logs of the first server, the number of hits on the first server, went up from something like 10 through 100, through 1,000, through 10,000. And what's interesting is that was pretty much straight line. In fact, it's two straight lines. That the number of people looking on the weekdays was always slightly more than the people looking at weekends. But that was an exponential growth curve, which was really remarkable in that it was such a strong exponential. It was always, the load on the server would double every 3 months, roughly. So it was clear that because it was exponential and wasn't tapering off over those 3 years, it was clear that there was no indication that it was going to stop. We call it a slow bang sometimes, like the Big Bang, but it's just happening over the months. So there was no plan really, but you could looking at that, you get an idea of how people were getting excited about the project. But remember, that was loaded on one server, and meanwhile the number of servers was also increasing exponentially.
Were there any surprises with how this was developing, things that you weren't expecting?
Well, a huge number of surprises. The number of exciting things people found to do with the web was just really gratifying. Very exciting when people produced the first web server which had really beautiful pictures on it. Those scanned in Vatican Renaissance exhibition manuscripts that somebody put on the web, being able to just follow through a silly little website with links, and then suddenly the whole screen filling with a gorgeous picture. That was a sort of a breathtaking moment. The first time somebody when Steve Putz made the first map server, I think that suddenly people realized, wait a moment, each of these web pages, it doesn't have to be a file, it can be something put out by a program. And every single time somebody clicks, the program can return something completely different. So the fact that you can move around the web, the map, I think then opened people's eyes. So bit by bit, the creativity that people put into the way they used the web was just great.
Did you expect that this was going to turn you into a public figure? And how did you feel about that?
That happened slowly over time. I think I built up a pretty good resistance to it. So, the same time that as I was putting the first web software together, we were expecting a first child. So we had these two children who were in lots of ways much more important than this study project. And it was also very important that they grew up just as normal kids. So I've had rules that in the town I lived that there was no discussion of the web really. They didn't give any talks about it or anything. So for 15 years or so, then it was really very much very low profile, and I wasn't really, I'm not somebody that people recognize in the street or anything. And around MIT, there's so many bright people who've done all kinds of weird things that that completely blend into the wallpaper.
Yeah, you could totally hide here. Okay, so as this is going along, you were increasingly, you came to understand that there needed to be standards, and that led you actually to come to MIT. Can you tell me how that happened?
Well, the whole design of the web is standards. The reason it works, the initial architecture diagram of the web shows that you've got different servers beneath the big connection bus, these servers connected, and different people browsing clients, people using the data connecting into the top of it. And the connection bus is the fact that they all connect in exactly the same way, that each computer talks the same languages. When you're browsing and your computer asks a server somewhere for a web page and pulls that in, and the fact that they've all got to use the same language, HTML, that's really important. That's why it works. And so now HTML started off as a really simple language, and it was a one-page specification. I just wrote it as I coded it up. Same thing with the HTTP protocol. And the whole idea of having these names for each document that sometimes start HTTP : those are URLs or URIs. Those are the three pieces of the architecture of the web. The really important thing was that all the web browsers and servers speak the same languages. Initially, when it was just me, nobody looking over my shoulder, it was easy. I could just write them up. And I had a little web page about HTML, a web page about HTTP. As time went on, and I got a visit while I was still at CERN from 4 people from Digital Equipment Corporation, among them Alan Kotok. Alan Kotok is, I didn't know that he was very much tremendously an MIT alum and tremendous MIT enthusiast, but he worked for Digital Equipment at the time, and he explained that DEC, the company, was preparing to revise its whole product strategy because of the internet and the web. He understood that the people he brought over were part of a committee which was planning the response to the internet. And he said, I believe that the system works on the specifications for the system are on some sort of a disk somewhere in your office, I understand. So, we're a large computer company. We like to be involved in the future of those specs. We'd like to be able to think about what features they need in the future. We'd like to make sure that we're concerned about their stability. And so I asked him about what he thought would be a good way forward, and he said, well, for example, making a consortium would be a good, like, for example, the X consortium, which had looked after the X Windows specifications. And And I asked him what's that form it could take. And he said, well, for example, you could base it somewhere like MIT. And the X Windows Consortium he said the X Windows Consortium was based at MIT, that it worked out very well for digital. So something like that would work. So that visit was followed by a number of months, again, in fact, a year or two for me. I did come over to MIT, went to the Lab for Computer Science for a month. I went to the West Coast, to Xerox PARC, stayed there for a month as a guest of Larry Macinta, and looked around, went to see NCSA, where they were, where Mark Andreessen was working on the Mosaic browser, and looked at different models for different forms of consortium and so on, and ended up deciding, yeah, Alan was right. When I talked to MIT, then Alveza, Michael de Touzas, knew how to do it. In fact, Michael was extremely supportive. Michael went to a lot of trouble to meet me in Switzerland when he was on a trip back to Athens. We met in Zurich, and in fact, I got his name from David Gifford. David Gifford, I met at a networking conference in the north of England somewhere in a rainy day when we had to get a bus from one part of the conference to another. I sat next to this guy, professor from MIT, and he asked me, so what are you going to do with this web thing then? And I said, well, I didn't really know. And he said, well, you should talk to Michael de Touzas at the Lab for Computer Science, MLD, at lcs.mit.edu. So I scribbled that down and said thanks, and I think David had previously discussed this sort of thing with Michael. In fact, there was a fairly deliberate plant of that email address. I've had a lot of support from David, and Michael turned out to be great, very hugely a huge person, larger than life and twice as natural, and also very supportive not only of doing it at MIT, but also of making it an international thing, making sure that it would have a leg in Europe, because I really didn't want to sort of leave, I didn't want to abandon Europe. That was very important to me, and he saw completely eye to eye with me on that.
So can you elaborate a little bit about what it was about MIT that seemed to make it the right place to do the consortium?
Well, for one, so MIT was a place full of interesting people. So it was important for me to be somewhere where I could chat to people. And I'd already had spent a month as a guest of Karen Sollins, who had been working on network names and names in the network and things. And I'd given a talk. Recently came across, in fact, somebody came across a copy of the announcement of that talk, which I gave back in '92. But so full of interesting people. But more than that, when it came to running a consortium, they'd run the X Consortium. Alveza had put together the contracts for the X Consortium. He was prepared to do it again, so long as it looked pretty much like the X Consortium. If I wanted to make something more like United Nations, he didn't know how to do that. But if I wanted to make an industry consortium based at MIT, then he did know how to do it. MIT, what was important for the consortium is that from the industry point of view, it should be neutral. It should be a place where different members of the industry can come together and talk about the future in such a way that they knew there was no inherent bias towards one of their products. So MIT, as an academic institution, and having done that very well for the X Windows system before that, I think that was one of the things that MIT could produce. But also it was the clout, there was the reputation, the fact that Al could pick up the phone, call 5 major computer companies and say, we're doing a web consortium, are you in? And they'd call him back and say yes. Well, it wasn't instant as that, but it took a few months. But that I think having it somewhere as credible with an international reputation as at MIT was really important getting industry on board, getting all of the industry on board, not just getting the people who happen to have come to MIT on board, and also making it clear that the fact that there was going to be one web was really important, and that that had to be really good design. It had to be really fair between different industries. It also had to be really technically good, and it had to be developed really rapidly, because in those days the web products were turning over extremely rapidly. So it had to work faster than any of the consortia or any of the standards bodies had worked in the past. So if MIT stood up and said that they were going to do that, then people believed it, and it happened.
Did you find a lot of resistance to standardization?
Well, there's always a resistance to when an engineer is sitting there making a design, they're designing something new. Web pages haven't had tables before, and they just, oh, we could put tables. I know where we could put tables. We could have tags, table. And then somebody else is designing the same thing. They don't know, but somebody else is making one where these little tags label tab, or somebody else has got table where the tag is T. And they're also excited to build web pages which got tables for the first time. They've all got users who are itching to use them. To actually get them to slow down and talk and agree to use the same tags, it's boring in a way. Besides, what they want to do is to get there first. What they'd like to do is get there first, so that everybody's using their particular form of tables. And if they can do that, then they won't have to recode their own. Everybody else will have to change their software to catch up. So they'll keep their lead. But so in fact, the ethos of getting everybody to admit during those early days, you know what, we're all in this together, and we're all smart, and we should respect everybody's ideas. That is one of the difficult things. It's been very important, but the Internet Engineering Task Force had had done a lot of that for the, so there was a track record of development of internet protocols in very much that way in which people who have working software were respected, because if they had running code, then that is respected. If you have crazy ideas about how it should be and you haven't justified it by running code, you're not so respected. So we took on a lot of that ethos from the Internet Engineering Task Force, the IETF, into the Web Consortium.
Has some of that resistance lessened over the years?
None.
None.
Because, as the Zuzos would say, it's a constructive tension. So what happens is, you get a good idea. You think I'm going to put tables in, and for a while the marketing department is saying, hey, our browser's got tables. A few months later, you know what? Everybody's browser has tables. And now the engineering department is having to write code which will accept 3 different flavors of tables. And so that's a waste of time. It's a waste of time for the users. After a certain point, it stops being a product differentiator. So then there's no incentive to make yours different. So now you want to make your code small, you want to make life simple, so you just want to settle down that the tag for table is called table, and the tag for table row is TR. And that's how it is now been since then. It's still, those are what the tags are for table. HTML is still developing, and we still have these tensions. There are still people who want to rush things into HTML without talking to other people, but there's a general understanding that you really you have to listen to everybody else, and because they also have got interesting products, even if they're different sorts of products that use HTML, and also even though you're really smart, there are also those other smart people out there. There are other smart people out there, and they might even have some ideas which, blended with yours, will be even better.
Well, it's a little discouraging that it doesn't get any better.
The constructive tension drives it forward. It's the urge to get out there in front, and then the need to have one web. The need to have one web so that you have one market, so that you have this huge galvanization of people using technology. But you also you have to have a lot of the drive is the urge to differentiate your product by putting something new in. So it's like a sailing boat in a way. There's a huge force pushing the sail this way, which left to itself would push the sail over. And there's a huge force pushing the keel this way, which left to itself would flip the keel up. But correctly managed, what happens is actually, when you take those two forces, then the sailing boat goes under control off into the future. So, and it's a bit like that. There are all these tensions, a lot of which are commercial, a lot of which are competitive, but everybody wins when the whole field advances, when the whole protocol, when HTTP becomes faster, or HTTP does something new, everybody wins. So there's so the competitive pieces all feed into the common piece, and the common piece advances very rapidly.
So much of the development has been prompted by people trying to make money, and yet you've been pretty consistent in your belief that the web technology should be free and open. Can you talk about why that was so important to you?
Well, going back to those days when the question of whether somebody would put up a web server, whether it would convert their information into HTML, or whether they'd use something else. Why would they? So I was asking them for every document they had, every page out there, give it a URL. Give it something that starts HTTP. So that when I look up that HTTP thing in my browser, I get a reasonable rendition of this information. That's a big ask. I'm asking everybody to do that. You can't go to the whole world and say, I want you all to give these funny HTTP things to your data, to your documents, without, and then come back and say, oh, by the way, and you're going to be paying me 2 cents a click or something. It wouldn't have happened. If I'd gone down that route, then there would have been lots of other people setting up different ones, incompatible ones. The web would have fractured into a whole lot of small ones. Small webs don't work. The small web wouldn't have taken off. It's only because the hypertext link can point to anything that it's at all interesting. So in order to keep that, you need to keep one web. In order to keep one web, it has to be royalty free. There was the story of the Gopher system. Gopher was a competing system in the early days. It was actually gaining ground faster than the web. The web was doing this exponential increase. It was doing this. Then at one point, the University of Minnesota, who employed the people who designed it, they sent around an email message which said that under some circumstances, not for academics, but only for commercial people, and not for people using the client, only for people using the server, but and not now, and anyway, not very much, we might charge a fee. And that's when Gopher did that. People just dropped it. So that was a trigger for me to go to CERN, and Robert Caillou, my colleague, just hammered on the CERN directorate to get them to say that CERN would never charge royalties for it. And it's been really important. And the WTC, the consortium, the idea that it should be royalty free has been really important part of the way people come together to design the new technology.
You've been working on the semantic web for, I don't know, at least 15 years now? Has it been 15 maybe?
Do I get to take away the mug?
I don't think so.
So the semantic web, in a way, I gave us some slides talking about web semantics, explaining the semantic web ideas at the first web conference back at CERN. So pretty much for as long as that was almost 20 years ago. So the idea that we need to capture the relationships between things, we need to capture the data, actually dates back to a program called Inquire Within Upon Everything, which I wrote way back at that first visit to CERN. Then I wrote a little sort of note card system, but it kept track of things. It wasn't a set of notes, really. It was a set of things. And the machine knew about things, and it knew about this program ran on this piece of hardware, and this piece of hardware was documented by this document was written by this person. Capturing those relationships I thought was really useful. And it was useful to feed them back to the person, but also useful to analyze them, useful to be able to generate diagrams, useful to be able to test, see what state your project is in, things like that. So that was way back. I've always wanted to do that. And it took a while to actually get it to happen and to get it deployed out there. So there's a basic technology, RDF, the Resource Description Framework, which was now many years old. And now we've got a whole suite of specifications in order for putting data onto the web. In 2009, I spent my time, some of my time wandering around talking to governments, explaining that they should put their data on the web, not just the documents, but the data. We need to be able to access the data so that we can compare it with data from other places, so we can join it with data, so we can analyze it. And that's been a really interesting little movement. It's been great over the last 2009. We just, a few weeks ago, at the beginning of 2010, launched a data site in the UK. There's a data site, data.gov, in the US, which is competing for the number of different databases it has in its collection. And so that's the simple way of looking at the semantic web. That it's data, but the important thing is that it's linked data, that it's data which connects together, just like the web.
How far along do you feel like we are toward a fully developed semantic web?
Well, if you asked Vint Cerf how far he was along to the development of fully development of what internet, I'm sure at every point he would say we're not there yet. Similarly for the web, similarly for the semantic web. We'll never be there. However, there's a time, I suppose, there was a point when the internet became a stable platform on which I could develop the web. The web then became a stable platform in which we could develop the semantic web, just by taking the web protocols and saying, yeah, we'll use the extensibility of the web to introduce new formats for data. So now we're at a point where we've got the protocols, we've got all the design of the semantic web really out there. And there are areas, there are people who are using it, people in life sciences are using it, they're using it for this lot of now linked open data, which is data out there using semantic web standards, which is just available about well-known people, about cities, about singers and bands and tracks and albums and all kinds of things that are interested the public. There's data about out there. So in a way, we've got a platform, but on the other hand, the amount of data which is out there, which is not on it, is huge. But more importantly, it's not just about data sitting there. It's really about machines communicating with each other by expressing themselves as in relationships and data in the web. So in fact, the semantic web is going to be an infrastructure for all kinds of really, really exciting new things which are going to come. And I think it'll be a few years before the basic semantic web, where its sort of publication of data and its query has been out there enough for us to see some really exciting new things built as a layer on top.
So give me an example or of two, or what I might be able to look up or find in 2 or 3 years that I can't do now.
Well, things that you can do now with the semantic web is you can ask. There's systems where you can ask things like, let me listen to music which has been written by people who were born in towns in Minnesota with less than 200,000 inhabitants or something. So this takes geographical information and information about people writing songs, which normally would be, you'd have to go to separate websites to see, but because that information has been linked together, you can now ask for music feed of places from your hometown, or places within 100 miles of your hometown, or only by female people from you, and so on. So that sort of query, if you gave a query for something like that to a search engine, it would come back with nonsense. So that's a query where really the computer has to understand what it is that you're asking for. And so you can do that now with the data that's out there, but it's only really the tip of the iceberg. The things which people will build on top of it, just like with the web, the great thing has been that it fortunately has not been limited by my imagination. If sitting here, we could think of all the things we could imagine being built on top of the web, or we could imagine all the things we can build on top of the semantic web. And in the next 50 years, all that comes to pass. That would be a total disaster, because really what's exciting is that we can't imagine. The people coming along, today's students now, have all kinds of crazy ideas. The ideas people have in the future will be wonderful and very powerful, partly because they're starting with the web, or starting with the semantic web as their foundation. So what we have to make sure is that rather than trying to think of how we're going to use it, we have to think about making people that are developing the web have to make sure that it's a really solid platform for the people coming in the future.
Yeah, it would certainly be limited if you and I were doing it because of me. But can you tell me a little bit about the World Wide Web Foundation and why you felt that it was important to start that?
Well, if when there was sort of 0.1% of the people in the world were using the web, we added us up and said, you know what, everybody in the world should be using this. That would be generally regarded as hubris and arrogant. But now that 20% of the world are actually using the web, that begs the question, what about the other 80%? And so for the last 15, 20 years, the web technology has been developed by people in places like MIT, people who are excited, people who carry several gadgets around in their pockets, people who have huge screens, very powerful processors, and constantly thinking about what they need out of technology and thinking how it could be better. So the question is the web designed by these people for these people? If the web were to be designed for somebody in a remote African village, would it be designed differently? What do we need to do to get the people who are not using the web into the information society as effectively as possible? We've got, I suppose, the first period of time which we've talked about was a time of building standards, deploying technology, and that continues, of course. Then we, after a few years recently, we realized that the web is now a really big thing. It's got 10 to the power 11 web pages out there. That's like the number of neurons in your brain. So the web, if we took the web and could somehow fit down into this size, what shape would it be? We know the brain sort of falls into two halves. It's got various bits and pieces, which it's got various organs within it, and which correspond to different functions in a rather curious fashion. But the web has emerged. The web wasn't designed as a set of pieces to fit together. It was just a protocol which allows things to grow. And as each thing grows, as somebody makes a link, or somebody follows a link, somebody reads a web page, somebody clicks on an ad, these are all people. So it's got this very complex system, which has got a structure which we don't know a lot about. And and which we rather depend on. A lot of people kind of find the web kind of useful from day to day, so it would be nice if we had some idea about the stability of it. And so that we realized that we need to really look at the design of the web, we need to look at the state of the web, we need to look at whether we should redesign the web to avoid instabilities, for example, or redesign it to be able to do things even more powerfully than it can do now. So from that came the idea of web science. And so a few years ago we started a web science research initiative, which has now produced the Web Science Trust. So that was a second way of looking at, a scientific way of looking at the web. There's the engineering way of looking at the web, which the consortium does. The Web Science Trust looks at this from the point of view of science. And the Web Foundation, it realizes that we need to do all of that, plus there's a social obligation. There's an obligation to make sure that we make sure it works. We've always made sure that the consortium has always made sure it works for people, no matter what culture or no matter what language they speak. We've also had a very strong accessibility initiative to make sure that it works well for people with disabilities. But now we've added another piece to it. It should now work not just on every device, not just for each type of document and all these and every language, but now we want to do it for every person. So the Web Foundation is aiming to look at that. It's a new foundation. It's very exciting times. There are lots of people who are doing work in that area that it's going to partner with.
So you hold a chair in computer science at the University of Southampton. Can you talk a little bit about this association between MIT and the University of Southampton and the reason for that collaboration?
Initially, that came out of the need to be able to talk about the semantic web in more than one place at once. I found that I was trying to spread the word about the semantic web. People would ask me to give talks, for example, in Europe, and I felt that it would be nice to have some people in Europe who that I had a close relationship with and who got it. And looking around, people, the University of Southampton, they've got a very strong ECS, Electronics and Computer Science school, and they have done They've done a lot of projects with a very practical bent, really demonstrating that it wasn't just nice theoretical technology, but demonstrating how you could do cool stuff with it. They got nice demonstrations. They'd taken all the data for a particular borough, London borough, and put it together. It demonstrated how you could really find out stuff about the London borough. They had some nice examples of taking, for example, all the restaurants in a given area and on a map showing which ones had the Michelin stars, and then comparing that with the reports from the hygiene inspectors, and looking at correlation of that. Finding data which lots of fun stuff. Taking real data and putting putting it into a system which allowed you then discover interesting new things. So I thought I found that by making a connection with them, that meant that I had a foot in Europe, but not only that, but also a connection with these people who actually got the semantic web out there, understood it, and could help drive the idea on the other side of the Atlantic. So that was really web science. And they also, Southampton folks helped start, and Wendy Hall really drove the Web Science Research Initiative and led that.
Having grown up and been educated in the UK, how do you see MIT being different than what you were accustomed to before you got here?
Well, I hadn't spent a lot of time in a big research university, so I've been to Oxford studying physics as an undergraduate, so I've never done a computer science degree. I hadn't done a second degree. So coming here and talking to graduate students who are studying computer science, I can help with ideas and technology and teach them about protocols and things, but I can't explain to them how they're going to get through their being a grad student at MIT. I have to learn from them. So in a way, MIT it's been really exciting. It's been really exciting meeting exciting people, faculty and not faculty, who with lots of ideas. Now it was the lab for computer science was interesting, but it was a sort of relatively boring building, and we went through that. We were in an office where progressively we were built around until the daylight was completely blocked out from our group. So coming to the data center, after that anything would have been wonderful, and coming to the data center where we are now was great. So we're on the 5th floor of the data center, which is more or less in the middle of the computer science space. So people come past in both directions. There are all these sight lines, so you bump into other people doing other things. So now it's, being on campus is a huge improvement. Being in the data center also, I find, I really like it. I think people either love it or hate it. And I find it's great because, partly because of its, the way people have to find their way past us in order to get to other places and end up dropping in.
Are there particular strengths that you think MIT's computer science department offers compared to other places in the U.S. or other places around the world?
Well, I can't really talk about the undergraduate curriculum. I'm not really qualified to talk about it because I haven't looked at them, and I haven't looked at the undergraduate curricula in other universities.
How about, what is it about MIT that's kept you here for so long?
I think, well, the people, the attitude to a certain extent, the general geeky excitement, the place where people understand that geek actually is a term of high praise, not a derogatory term to start with. There's a certain type of person who feels, sort of walks in and feels very at home when they arrive at MIT. The lunchtime discussions, anything which can wander off into something philosophical or something technical or something mathematical or something curious or generally intellectual is I think makes that whole spirit makes it a great place to hang around. It also indirectly makes it a good place to be because people appreciate coming here. So you can, so by having, it's a, I suppose, self-fulfilling thing that once it has a reputation of being a good place to come and speak, then you get good people to come and speak, and you can invite people to come to present their work, and they'll be proud to do it.
Can you give me that description of the person you think comes here and feels at home right away? Like, what person is that?
Well, the person probably doesn't expect to be judged by their clothes. So certainly the people I work with, they wear all kinds of things, and so you can't look. There's no typical. So some of them wear shoes, some of them don't. Some of them wear lots of clothes, some of them dress rather carefully, and some of them have no idea what they put on in the morning, and they have to look down to see if you ask them. So it's what sort of person? The sort of person who lives in an intellectual space, a person who's curious, and I suppose, and people who are creative. I think that a lot of people don't realize, perhaps, when in high school they're given the options of what to do, that computer science is really a very creative thing. I think people look at it as being sort of learning about how to make a laptop work, or how to build a commercial IT information technology system, which may be boring. But whereas I grew up when my parents were working with the first computers, it was clear to them, because of Turing's work, that anything you can do on one computer, you can do on another computer, because computers, in a sense, they're universal machines, so that if you can imagine, to a certain extent, if you can imagine it, you can program a computer to do it. And that is quite a challenge. It's a gauntlet thrown down to anybody who thinks themselves, who's ever, to anybody who's complained that a computer won't do X. So people who realize that that actually, if you want that done, if you find yourself doing something which a machine could do, you know what? You could be programming a machine to do it instead. It's that sort of person. People who realize that, when they're dealing with somebody else's program, who when they, rather than just complain about it, they fix it. So it's that sort of person. That's people all over here. Which leads to it. So that is very creative, and there's a huge amount of creativity. So there's creative people.
Have the options for collaboration been important to you here?
Have the options. Well, remember that the whole web is supposed to be this big collaborative space. So the way the Web Consortium works is that you work in the web. To be fair to people who are not in the room, everything has to be in the web. If you have a meeting and you bring a document to it to discuss, if it hasn't got a URL, it doesn't exist. Because when you talk about it, somebody's going to drop the URL into a common chat session for the room, and everybody in the meeting, remote or local, will be able to click on it and see the document. That's how we work. Whenever the minutes refer to a discussion, the discussion will have links to the documents. So we've got this. So I'm used to working now in a situation where everything, fundamentally, things exist in the web. If you print a copy, it's a temporary thing. It's curious, so when I then find myself working with lawyers or government departments where the paper copy is the fundamental thing, and if you want to scan it in, that's the ephemeral thing. That's very odd. So the collaboration that happens is collaboration which we try to actually make work internationally across the web. And that's very exciting. So the consortium is a huge collaborative engine. It's designed to get people to come together to agree on how to go forward, to get consensus among very creative people. So the whole consortium has been a collaborative system. So, and it's sitting within MIT. There have been lots of times when it's been nice to be able to collaborate with other groups, the theory group, the theory computing group, there have been lots of interesting collaborations. It's always good to, so David Carger and I will walk into each other's offices occasionally to bounce ideas off each other, and all kinds of things can come of something like that. Akamai, the company, sprang out of a discussion about what are the challenges, the theoretical computing challenges that the web poses. And I'd said there are lots, and somebody said, okay, what are they then? So, and hence Tom Layton and starting Akamai. So, it's great also, of course, everything nowadays is happening in life sciences. It's been great to have people doing life sciences bring their data to the Semantic Web. A lot of the early adopters of Semantic Web technology, a lot of the great data sets have been about proteins and genes. So they've been very enthusiastic early adopters of the technology there. There are lots of great collaborations.
You have quite a list of awards and prizes and honorary degrees and things like that. I'm wondering if that kind of recognition has been an important part or an annoying part, or how have you reacted?
I think I initially reacted by putting up a pretty good defense against it, most of which I've got still. I found that I was being asked to speak more and more often, and then I realized that I found I had to say no because I would have conflicts. And then I realized that when I said no, nobody actually died. Nobody was really hurt. They found somebody else. So then I realized that actually I could say no to the other people too. So I could just do, and then and Dame Rennie Fritchie in the UK gave me this hint for the beginning of the year, figuring out what sorts of day you wanted to have, whether you want to have days by yourself, days with your colleagues, days doing something public, days doing something for a community, days doing something for income, so on. And she would collect different numbers of different coloured marbles. And when she did something, she would take a given coloured marble and put it into a big bowl she kept on the windowsill. So, and if somebody called her and said, could you possibly come and speak to these very deserving children who've just been shipped up on refugees who have come from Vietnam, or even if they were very demanding, if she would say, I'm sorry, I'm out of green marbles. So that sort of technique for just keeping things, deciding how you want to balance your life. Also, I was under a lot of pressure to to make sure I had a good family life spent, and so I used to measure the cost of a trip in sort of bedtime stories missed in those days, and so that pressure, which was very healthy, I think, kept me from zooming around the world too much. I mean, honorary degrees and things. So I used to generally decline honorary degrees because I thought they were a sort of vanity thing, until somebody at a dinner faced me with the fact. He said, "No, we want you to do this because and it's your duty to do it because we need you to be a role model for the students. You had a project, you wrote a program, it worked, okay, and so." You have a duty to do that. So that changed my attitude to honorary degrees. So I sort of now try to do some of those, to accept some of those, but always try to fit it in somehow so that I don't end up having to spend too much time going around the world. So the recognition. I mean, in MIT, I'm just one of them. Lots of people here. The town where I live, people. No, I'm just an ordinary person. The fact that I've got Sir in the passport sometimes means I suspect I get through passport control a little bit faster. Sometimes it opens.
They don't do the body search on you?
They still do the body search, but then they say, "Hey, what is this about?" And sometimes it takes longer, but that can open some doors, and so it's meant that I suppose from quite early on I found I'd meet really interesting people. So that has been a big bonus, being sort of going to places and just being introduced to people who've done all kinds of interesting things. Having this sort of inventor of the World Wide Web little sort of tag mode. That's been interesting, but on the other hand, you can't spend all your time zooming around the world. Have to balance things.
How many times when you're introduced or explained as the person who invented the World Wide Web, do they come back and say, I thought Al Gore did that?
About 25% of the time.
Yeah, I've been hearing that a lot too.
And then, of course, a lot of the times they introduced me as having invented the internet, which was 20 years before. Very different set of people that we all owe a lot to. But trying to explain to a typical audience the difference between the internet and the web is really difficult because they don't remember what it was like. They didn't know the internet before the web. And trying to explain to them what it was like is really hard. It takes sort of 45 minutes.
Are there any of these honors that particularly pleased you, like the MacArthur Grant, or, did anything?
Well, the Millennium, the MacArthur Grant was very early on, so that was quite a surprise. I'd never heard of the MacArthur Grant when I got it. So it was really being sort of woken up and called at some ungodly hour of the night. So that was a surprise. The Millennium Prize in Finland was it was a big prize, and I was the first person to get it. And the Finns are tremendous hosts, so that was quite a day. And that was also the time that we broke the rule of not involving the children at all. So they were, our youngest was 10 then, and in fact his 10th birthday was on the day of the ceremony. So he ended up being completely celebrated, had 5 birthday cakes. But by that time he learned that actually, that whatever Daddy did, it was no big deal, and he learned to be sort of cool with being photographed, and he learned to take it. They both learned to take it with a huge grain of salt.
So they've grown up to be, your children have grown up to be relatively normal?
Oh, what a horrible idea of them being normal. They're wonderful people. They're wonderful people, and they're completely unique, and full of all kinds of stuff, and very different from both of their parents.
Isn't that wonderful when that happens? Is there anything that we haven't talked about, particularly about your impressions of or feelings about MIT, that you think would be worthwhile to say?
We've talked about Michael Detouzos. We've talked about so that and Alves are putting together the consortium. That was a very initial, very supportive sort of thing. Actually, I found out later that also I think that Chuck Vespers was present at the time, but I think Michael and I had a lot of support from Chuck. One of the nice things that I heard from Chuck later that after he'd retired from being president of MIT, that when looking back, the 2 things that he was most proud of, he said, for when he was during his time there, were the OpenCourseware and the Web Consortium coming to MIT. So that was really nice. So I think there's been, I suspect that I may find out as the years go by the places I've had support from, which I never. Sometimes support has come from places where very, very quietly and anonymously, and you only find out indirectly later on where people have really actually played a role in making things happen. And so I'm very far from understanding how the institute works, but so far it's been an exciting time. Recently, Susan Hockfield organised a trip to Davos, the World Economic Forum, with I think 17 MIT people went. I was in a group of 5 people giving back-to-back 5-minute talks, which is frightening. So
Sounds like speed dating.
I put my slides on. We all ended up putting our slides on videos, so that we just perform in front of the video because there wasn't time to actually press the slide button and move on to the next thing. So you could actually stage manage the whole thing beforehand. So that was that's just the most recent thing we've done. That's been very useful. Having going to the World Economic Forum, where are lots of interesting people to meet and talk to about all kinds of things, web related and other. Coming with an MIT badge, gives you immediately a lot of respect. It opens doors.
How do you think MIT is seen abroad?
Well, I know that, there's two things conflated there. I think MIT is seen with a lot of respect abroad. I think that, of course, how Europeans think about Americans is something altogether different. So I think there's a lot of disdain. I think there was, when initially the consortium started up, there were some people who were very upset about the idea of MIT running the consortium. They felt it should have been done by something European. So I think a little bit of competition across the Atlantic has always been a good thing. But recently we had a good competition between the UK government and the US government putting their data online, and each leapfrogging the other, and that's pretty healthy. But I think MIT, the name of MIT opens doors abroad. I think it's really important that MIT doesn't get arrogant about it and makes sure that it works very hard to deserve it. Also, I think it's really, I think it's there are lots of other great universities around. There are lots of great research centres with wild, wacky people as well. And so I think more and more, partly through the web and partly through everything else, I think more and more MIT will find that it's part of it's part of a global morass of fun and exciting things happening. But then lots of places, like with OpenCourseWare, for example, it's pretty much been the leader. I think OpenCourseWare is one really, really exciting thing. The Web Foundation has now taken me to Africa, where in developing countries, where you meet people who've really put together courses using MIT OpenCourseWare. It was an MIT idea, really, and which other places have picked up. Another way they're changing the world.
It sounds like you like being associated with it.
Yeah, for the moment.
What's your current focus of your research?
Well, the Semantic Web research, I've only had a little bit of time to do. In fact, most of the coding has been done by undergraduates, which is great, by Europe's, and for my own little pet project. So in the decentralized information group, we've got various people working on semantic web related things. Lana Kagal and Danny Weitzer both work on the side of policy-related things, that is, machines which are aware of the social aspects of information. They process information, but they're aware of where it comes from, whether to trust it, who should be given to, what sort of use of this information are appropriate, tracking all that, making more responsible machinery. There's the challenge of how to make, if we've got all this data out there, all the semantic web data, supposing you give somebody a really big screen or really big goggles and all the keyboards and joysticks that they could possibly imagine, how do you give them the ultimate interface to all the data that's out there? That's a pretty big challenge. The user interface to the mass of semantic web data, and we've just started doing that. So those are some things happening in the decentralized information group.
Is there anything that you have planned to tackle in the future? Do you have a list of things that you want to work on?
Oh, have I got a list of things? So in W3C we call that the someday pile, and it's huge. Yeah, I mean, I've got the list of things. It's just, yeah, should I be excited about that or depressed about it? The number of things which I'd like to do, projects I'd like to do, things that I'd like to try out, challenges which have We'll never have time to write the grants to do, yeah. There are lots of things, and of course it's a continually changing world on the web. So as the web develops new technology, then it suddenly becomes a different sort of place. There's analyzing that, understanding it, and then developing new things in that new environment. So it's constantly changing, as a constantly changing environment as well. So new challenges. The whole web science thing is really it's very multidisciplinary, of course, because the web is the web of people connected. So you need psychology and you need sociology to understand it, as well as computer science and math and things. And it's a big system, so you need complexity and network science. And so web science is really new in that people haven't really put together multidisciplinary groups to work on all the challenges of the web. So it's bigger than computer science. And it's in the early days of defining its challenges. It's in the early days of just defining even the curricula for that graduate students should go to participate in it. So it's not as though we're anywhere near seeing the end of this. It just gets more and more exciting and bigger and bigger.